Good evening, guys. I'm audible. Yes, no. Okay. So in today's class, we have planned that we will be covering. 1 second. Okay. So it will be basically a revision class. In that, we will be revise whatever we have learned till now, and we will be solving a lot of problem with respect to whatever we have learned in algorithm analysis. Okay. With respect to the recursive solution as well, we have seen the recurrence relation. Based on that, we are deriving the time complexity of a problem, है ना? So we will be solving more problem with respect to that, and we will revise that. Yeah, Nishant, we will revise that substitution method once again today. Okay. Okay, good evening everyone. Asymptotic analysis speaker notation due to my office work. Nilanjan, if you haven't attended that particular class, then I'll highly recommend please watch that class. But in this particular class, we'll revise that everything once again. Okay? So no worries. You can also watch this class. Okay. So on that note, can we start our session? I'm not able to complete assignment problem due to work pressure. No problem. Try to complete as soon as possible. But no, in this particular class, we will be solving the problems which is far more important as compared to your interviews and as compared to your technical knowledge is concerned. If you understand this particular problems, I'm pretty much sure that you will be solving, like you can easily solve the assignment problems as well. Okay, some of the problems from the assignment I'll take, some of the problems that apart from the assignments also will take today. Okay, making sense people, है ना? ठीक है, चलो. So on that note, we will start first of all the algorithmic analysis class. On the very first class, whatever we have learned in the algorithmic analysis class. Okay. So in the first of all, we learned that what is algorithm, है ना? We learned that what is algorithm. In the algorithm, let's say we learned about the first thing that was our algorithm. The algorithm is nothing but our step by step process or step by step instructions to solve a particular problem, you know. So suppose if you want to prepare something, you first of all you need to take some steps, right? Suppose if you want to go to your office, then you have to wake up, you have to take a bath, you have to brush your teeth, you have to take a breakfast, you have to take your cab or bring a vehicle, you have to go to the office, and then you will start your work. So this is what the routine you follow in order to go to the office. So the same way, if you solve any problem, if you want to solve any problem, that will be come up with the step by step process. That is what we call in the like in the programming language, algorithm. Okay, that is what algorithm is. And I also told you that anything you will learn in that, 10% of that will only be concerned about the coding. 90% of it will be the algorithm which you will derive, है ना? ठीक है. So first of all, you have to think about the problem, you have to read the problem statement, you have to devise the algorithm for that, then you have to code the algorithm, है ना? We saw that particular steps, yes or no, है ना? First you have to think about it or read the question, then you have to think about the logic, or we can say you have to devise the algorithm, and then you will code it, है ना? Yes or no? Then you will code it. But the more important step here to think about the algorithm steps or the logic, that I'm pretty much sure everyone would be here would have faced this problem. Okay. So remember that there is not a single way to solve any problem. There will be multiple ways or solutions of the same problem that we have already seen. Okay. Whenever you have any problem, you can solve it not just single way. You have a multiple ways to solve it. It's just like your lookout how you can solve it, how easily you can solve it. Okay. Suppose I gave a problem to Dipanshu, Mahek, Ekta, and Priyanshu. Okay, to write a problem or a solution of that. Okay, but as a teacher, my concern would be that the problem should be having a proper answer. and the answers process or answers the logic, that should be the optimum one, or we can say the performance of that should be the very faster, है ना? ठीक है? So provided that first, what was my first condition, that the problem's answer should be proper, or as I can say, your solution should work. If your solution is not working, then there is no sense of moving ahead, है ना? ठीक है? Yes or no? That is what is needed, है ना? That is what we have seen, why we need these particular things. Cool. Now after that, for an example, we took an example that if one guy is having like suppose, let's say Joseph has written a problem, you know, and Nilanjan also has written a problem. Now Joseph's code is running in 3 days, and Nilanjan's code is running in, let's say, 15 minutes or 20 minutes, comparatively very less. Okay. So on that particular case, I can say that the code of first guy is proper. Sorry, second guy is proper because it is taken less time, है ना? Less time to execute. So this is what a layman's term to see a problem solution. But we have to think about the some other way also. Let's say we took an example. In that particular way, we took an example, I guess so, a flight, है ना? So wherever you have to go from A to B, you can go from multiple ways, है ना? You can either choose flight, you can either choose your own vehicle, you can either choose a cab to go here. Now let's say it's my flight, it's my cab, and it's my own vehicle. Okay. So on that particular three perspective, now you will ask me, sir, which is better? So I'll ask you on which particular basis you are asking me the question. Like, what is your meaningful criteria? Let's say if your meaningful criteria is cost, then obviously your own vehicle would be the cheapest one. Similarly, for every other criteria, some answer would be better. You cannot choose a one answer every time. There would be multiple answers, or there can be multiple choice depending on your requirement. Okay. The same goes for in algorithm as well. There can be multiple solution of a same problem. It depends how, like, what is your requirement and what is your goal to achieve. Like, you are concerned about time, you are concerned about only the solution, you are concerned about the space. What is your concern? On depending on that, we will be deriving a output. Okay. Now now uh we discussed about the goal of an algorithm. If you remember, we discussed about the goal of algorithm analysis. In that, we saw that there will be two goals of it. Let's say, like, there can be the two comparison terms, you know. The first one, which will be our time complexity, and the second one will be much obvious one, that is our space complexity. Okay. Okay. Now, in your I then after I told you that everything, like, if you take an example of any coding round, let's say if you code in lead code, if you code in hacker rank, or else if you code, or if you give an examination on re-level, it's also okay, on re-level also, they will be depend, like, they will derive, or they will assess your solution on three bases. Okay. The first one would be, obviously, your solution would be the proper one, or else I can say it should work. Okay. The solution should be correct. Okay. The second one, let's say if one guy is A, one guy is B, both of them have correct solution. Now I have to evaluate as a, no, as a compiler or as an interpreter, that which is the better one. So then after, I'll check about the time complexity, and in the rare to rare case, I'll check about the space complexity. So this is very critical to learn, guys. If you don't have exposure in this, if you don't practice it much, okay, right now, like, there are like multiple levels of time complexity. Okay. Let's say if you want to learn like, if you want to learn English language, then first of all you have to learn alphabets. Okay. Then after, you have to learn about the words, then after you can make a sentence. Similarly, we have just learned about the alphabets now in terms of the time complexity and space complexities. Okay. We have just learned about the alphabets. We are remaining yet to learn about the words and the sentences. Now, as time progresses, we will learn through it, and you will have a exposure in this. But first of all, if you want to make a sentence, if you want to make a word, then there is a necessary to learn about the alphabets better. If you don't have like if you don't have exposure in this, nobody can teach you this. है ना? I hope everyone would agree with me. Correct? ठीक है ना, people? Okay. Now, on that note, uh, after that we have started about the how to do algorithm analysis. Now this is something which is which is discussable topic. Till now everything was a common sense. You know, this is also common sense, but this needs your attention to understand it. Okay. Now then after we had quickly started with how to do algorithm analysis. Guys, please focus in today's class because this is a revision class. है ना? I will also give you task after doing every revision thing. I'll also give you some task to perform. In that I want answers from everyone. Okay? I want participation from everyone. So please focus on today's class. Now, in the first thing, there are two ways of doing this algorithm analysis. The first is our obvious thing, that is our experimental analysis. Now, for those who have missed this, or you for those who have some 0.1% doubt in this, let me explain you in layman term. Okay, so for an example, uh, 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 okay, for an example, if this is my A guy, this is B guy, okay, or else let's say take a name. One person is Aradhya, second person is Nishant. Okay, this both guys are very intelligent. They are participating in the class. They are participating in doubt session. They ask good questions. They do revision time to time. They complete their assignment time to time. Now, at the time of examination, at the time of examination, I have asked five five problems to both of them. Both of them have cleared these five problems. I now, as an examiner, I have to I have to analysis. I have to analyze which is the better one. Okay. Now they both are very smart. Okay. Now what Aradhya will do? Aradhya has his own Mac. Okay. He has his Mac. Nishant has just pen and paper. Okay. So he has written his algorithm on Mac. He has successfully run that, and the compilation time for him is what, 3 seconds or many milliseconds, not 3 seconds actually. Okay. Now since Nishant has just pen paper, but he is also very brilliant, his algorithm is also up to date. Since like he doesn't have a compiler, he doesn't have a IDE to execute. Since he has written it, he has executed it in his mind. He himself a debugger of his code own. So for that he has taken a lot of time, and let's say he has taken 1 hour. Now, if you just look into like this, you don't know that he Aradhya has Mac, Nishant has pen and paper. If you just look at this way, that Aradhya's algorithm is taking 3 seconds, Nishant's algorithm is taking one hour. But this is not a proper way, है ना? If you say that Aradhya's code is proper, होगा proper, but this both cannot be even comparable, है ना? If you want to a comparison, then both should have a same standard, both should have a same resources. Apart from that, we cannot compare both of them. Okay, so on this particular case this cannot be comparable. Okay, we cannot compare this two, since this both guy don't have a same requirement or same kind of things. So this is what an experimental analysis is. If you tell me the by just looking the answers that one guy is proper, one guy is not, this is not a this is not done, है ना? This is what a experimental analysis is. So to get rid of it, to get rid of this particular thing, we introduced a second kind of analysis, which is called as asymptotic analysis. Okay. Now, can I say that in this particular case, my time period or my judgment would be based on the this time period, है ना? But how come this time period has come up? this time has come from this particular Mac, this time has come up from this system. Okay, okay, right? So this particular algorithm is what, machine dependent. Now every time I cannot run, let's say I am organizing a coding context, I have thousands of registration. Okay, now for everyone I cannot run that particular code on a specific one system which is having the same configuration, you know. I cannot do that. This is not feasible solution, right? You know? uh no, Joseph, today will be the like revision class, and in that we will be solving problems, more like more problems. Okay, in the previous class we have solved now like Fibonacci series and all. In this particular class we'll continue that and we'll solve some more problem regarding to that. Making sense? Now in this particular asymptotic analysis, in asymptotic analysis, as per like how did this arrive, we have to get rid of the disadvantages of the first system, है ना? So we don't want to rely on machine. It makes situation very bad, so we don't want that. So for that we have introduced asymptotic analysis. Now what does this say? That we have to compare algorithms based on the input rate of growth. Okay, we have to compare algorithms based on directly proportional to, based on the input growth of algorithm. Okay, so let's say again, this is Aradhya, this is Nishant. Now for Aradhya, he has written his code. Let's say I'll name it as solution 1. Okay, solution 1, and this is my solution 2, which is written by Nishant. Now solution 1, when I will run with, when I'll run this particular solution with n is equals to 4, let's say. Okay, for an example. So can I say that hypothetically it will take 4 computer steps? You know, if I have just written simple code, hypothetically just assume that it will take a 4 computer steps. Although it's not true always, you know that. But let's just hypothetically just consider that it will take 4 computer steps. When I'll take n equals to 100, can I say it will complete in 100 computer steps? Right? You know? Okay. Now for n equals to 4, his algorithm has completed. His algorithm has completed in minimalistic time. In minimalistic time, right? So let's say it has taken, let's say 3 seconds. For 100 input, it has just taken 4 or 5 seconds. Similarly, with the case of Nishant, for the first case, it has also taken 3 seconds. And for the case of 100, the system has completely collapsed with this particular solution too. Okay. It has taken, let's say, 1 minute to tick. Okay. So comparatively to 3 seconds and 1 minute, it's like very big difference in between the both of them. Okay. So I can say that this is a better, but there are some criteria to evaluate that as well. Okay. So, uh, let's say what my task here is just to print the numbers. Okay, let's say my task here to print the numbers. Let's say if I have n equals to 4, then I have to print 1 2 3 4 like this. So what I'll do, I'll just iterate through my array. I iterate through array by any loop, and I'll just print the number. I'll do the same now. You will also do the same. This is my first step, this is my second step. Yes or no, people? Right? Can I say if I have to just iterate through an array, this will take 4 steps? This will complete me in the 4 steps. This will complete me in 100 steps. Yes or no? Everyone agrees. What do you mean by computer steps? Are you clear? Because everything after that will be depend on the computer steps only. You know? Right? Okay. Now, this is what our computer steps. I can say computer steps is. Okay. Now, let's say so since you know this, since you know what are the computer steps, can I say, like, first of all, let me just tell you that there will be 3 criteria. Like there will be the 3 types of measurements. First was the best case, second was our worst case, and third was our average case. Now whenever, let me write it in a proper way. Okay, let's say second will be my average and third will be my worst. So whenever I'll say worst, whenever I'll say this worst, it will be always, always, always denoted by this big O. Okay. So whenever I'll write this big O and I'll write something here, immediately this worst case scenario should come up into your mind, in your mind. है ना? It, ठीक है? Now, in case of average case, can anyone remember what was the symbol for that? Everyone? Theta, na? Okay, so whenever I write this theta, it will denote that I'm writing the average case for my algorithm. And for the best case, it will be what? Omega. Symbol of that is like this. Okay, so this is a symbolic term of best case, average case, and worst case. Now, now the problem here, the question here that sir, how to calculate this worst case? Okay, so worst case is nothing but people. Worst case is like again it's like MRP. Whenever you have a product, nobody will ask how less you can sell it as a vendor, है ना? You will always ask how maximum I can sell it, because so that my profit will be increased. Let's say I have a packet, like I have this packet, I can sell it at 10 rupee in Bangalore. So if this MRP, if this is my MRP of 10 rupee, then I have to, I have to sell this no matter what at 10 rupee only in entire India, correct? है ना? But let's say if I have a same product of 10 rupee and its MRP is like 50 rupee. Okay, I'm getting this product at 10 rupee. So can I sell this particular product at 50 rupee? After this 50 rupee, I cannot sell it, you know, because it's like maximum retail price. Yes or no, people? You getting my point? So this play a vital role whenever you are selling something. Similarly, in case of the time complexities, in case of time complexities, the worst case plays a vital role to deciding, like it will be the deciding factor of your entire algorithm, because everything would be judged on basis of this. If your worst case scenario is taking less time, let's say if my worst case scenario is taking n time, okay, है ना? So can I say that my best case and my average case would be less than that? Take an example of here. If my best case, if my worst case is 10 rupee, can I say my everything, like this is my maximum price? I can sell, I can get my product less than this, but not greater than this. Yes or no? Correct? Right? Okay. So that is what our scenario in case of worst case. This is what the fundamental of worst case. है ना? Now, in the best case, it will be always on time. Let's say if I have an example, if I have an example like this, that just a second, yeah. If I have an example like this, that I have to, what? Let's say I have this array. Okay. Now, in this particular thing, I have to print all zeros. This problem we have done. This problem we have done, people. If you remember, we have to print all zeros and all ones. If you remember, in the arrays. Yes or no? Now, can I say that in this particular problem, if I have this is my input, right? Now, let's suppose my input is this. Now, in that particular thing, I want my output as like this. Okay. Those who don't remember this, I want my output as this. Now, can I say if my input is like this, I'm done. I'm done. So this is my best case. This will be my best case, people. Yes or no? Yes or no? So sorry. Just a second. Yeah, just a second. Just a second. 1 minute. Okay. Yeah. So can I say this will be my best case? Yes or no? because everything is sorted, everything is given by God, है ना? I'm God gifted because whatever my input, this will be my output. So this is what my best case is. Whenever you want, like suppose this is what you wanted, है ना? This is what you wanted. So if you get what you wanted, this will be your best case. Like इससे best क्या होगा, है ना? You want 1 lakh of rupee, you found that you won a lottery. What best out of this you can do? No, nothing, na? Because this is what your limit is. Up to this point you can imagine. So you got that. If you thought about 1 crore of hundreds of crore, you would have also got that, है ना? Right? And what's to worst, what can happen in this particular case of lottery? You will get 0 rupee. Yes or no? You have to earn this particular 1 lakh or 1 crore or hundreds of crore. Yes or no? In this particular case, what will be your worst case? In this particular case, what will be your worst case? Your worst case would be look like something this. ठीक है? अब करो. Everything should be arranged. है ना? First of all, I wanted 0, but I'm getting 1. Then after I wanted 1, but I'm getting 0. This will be my worst case, right? है ना? Everyone got this particular thing. What do I mean about my worst case and best case? So that is why Dipanshu, yeah, Dipanshu, this will be, see, you cited like this example, 1 1 1 1 1 like this. This will be your worst case. Like this cannot be sorted also, right? है ना? But it we have to iterate on this, है ना? Let's say if you have a 0 1 0 on it, this will be a worst case because you want output like this. Yes or no? है ना? So you have to work with your utmost efficiency here. Every loops will be run maximum time, है ना? Right? Now I was talking about something. Let me remember. Huh. So I was talking about that. In case of this, can you see here that you are bothering about the worst case only here? Okay, can I say that this is completed in 5 seconds? This particular task, this my worst case, it is completed in 5 seconds. So can I say my best case and my average case would be taking less than 5 seconds always, much less than 5 seconds always? Can I say that? Yes or no? है ना? So that is why we always talk about the worst case only, because after उससे ज्यादा तो कुछ नहीं होगा, है ना? इससे कम ही होगा हर बार, राइट? ठीक है. Now on that thing, on this is, if this is something it is clear to you, now let me ask you something that, uh, guys, please tell me that if I have a equation like this, let's say y is equals to mm, 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 50 plus 100 plus 20 into 6. This is what my equation is. Can anyone tell me how many steps are here? Dilanjan, not always. At some point of time, you can consider like 80% of time your worst case would be equals to your average case, but not always. We will look into it in the next session. Like in the from the next session, we have a sorting algorithms. Okay, so in that we'll see in detail. I'll show you the differences. Now in this particular case, if you see how many computer steps is taken here. This is my first operation of multiplication. This is my second operation of addition. This is my third operation of addition. Can I say this is my fourth operation of assignment? Yes or no? Right? So can I say this will be taking like 4 steps on, like on an average? Yes or no, people? है ना? So since this is taking my 4 step, now every time whenever you are writing this big O, which is your worst case, you would always write it here, whatever a computer steps would be at larger level. Okay, whatever your computer step was, you have to write it here. So can I write 4 here? है ना? I can write 4 here, but since this 4 is nothing but my constant operation, I can neglect it and I can just write 1. Okay, this is your first rule, that you have to always omit your constant terms. Okay, now if you see here, it is not depend on input n, है ना? There is no n here. So in every machine, the output will be the same one. है ना? In every machine, you will be taking this much of steps only, and in every machine, you will be taking order of one only. So remember, in interview, 99.99% case, they will ask about the complexity of worst case only, because the best case is like always less than of that. Now, since this particular operation is clear to you, uh, can I give you some other problem with respect to some, like we'll do something. Let's say we'll take every possible solution here, we'll take every possible like problems here, and then after we'll quickly move to the recurrence relation. In that I have to cover a lot of things. Okay, so we'll emphasize today's session with the recurrence relation, how to put like substitution method, and how to solve that particular methods, because this is what you will be worrying about. Okay, so let's say if I'll take about this example, if I take this example, okay, every constant is ignored. Yes, every constant will be ignored and it will be order of 1. Okay, now suppose, can I say like this, I don't know we have covered this example or not, I don't remember it. Because if we have covered it, just tell me the correct answer, and those people only will answer, will I'll ask. Okay, nobody will answer randomly in the comment section. Now I'm gonna write the question. uh, 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 let's say I have something like this: for I equals to 0, I should be less than n, I plus plus. Inside that I have, let's say, print I. This is what I have. Second thing what I have is j equals to 0. J should be run n by 2. Okay, this is n by 2, j plus plus, and here I have some code. Okay, this is what my problem will look like. Okay, let's say I'm taking here also like print j, like this also I can take. Now something like this is what my problem is. You have to calculate the worst case of it. Okay, you have to calculate the worst case for me. Okay, easy peasy. Huh? Easy है ना? Now, I'll say whom will answer. Just a second. Uh, 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 Vishal, are you in the class? Okay, order of n. ठीक है, चलो. Everyone agree with Vishal? So fast. ठीक है, चलो. If everyone is agreed, let me tell you how. So okay, everyone is clear up to this, है ना? Because this will take whatever operation in whatever I'm specifying in this n, that much of time this will loop will iterate, and that much of computer steps it will taken. So can I say it will take order of n, है ना? Because for if I'll take n equals to, let's say, 3, then first of all my equals to 0, I equals to 1, I equals to 2. This time my loop will run. So how many time it will be there? 3 times. 3 is what? My n. So can I say it will be run for n time? Yes or no? है ना? In the second loop, if you see, it is specifying that it will be specifically run to n by 2 times only. Let's say I'm taking again my n is equals to, let's say, mm, 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 uh, 6. Okay, I'll take example of 6. So first of all my j will be 0, है ना? First of all my j will be 0, and it will be run how many times? It will run how many times? N by 2 will be what? 3 in the first operation. Second time n by 2 will be what? 1, है ना? And third time what will be my n by 2? What will be my n by 2? This will be my 0, this will be my 1, and for the third time how many time it will run? 0 na, right? So can I say it will run for 3 times, right? So can I say that it will run for how many times? Order of n by 2, because 6 by 2 is what? 3. Yes or no? So if you see here, that my first loop was running for n times for any n, okay, for any computer, like for any n. Here I have taken n equals to 3, here I have taken n equals to 6, but if you take n equals to 6 here also, it will run for n time. Now this, since statements this both statements are sequential one. Now what do I mean by sequential? They are not inside each other, they are one after another. After I'll do my task with this, then after only I'll start execution of this. Okay, so after this I have to do this. That is what sequential means. So whenever you have a sequential thing, sequential statements, you will add your multiplicity or else time complexity. Okay, so this will be what? Order of n plus order of n by 2. Now as we have already discussed that, can I ignore this n, like 1 into n divided by 2? So can I ignore this 1 by 2? Yeah, what I mean to say that this is what my order of n plus, can I write it like this, 1 by 2 into n? So can I ignore na? This term can be ignored na? So can I write it like order of n plus order of n? So this is nothing but what, which is max in both of them, like both are same term na. So anything you can write like order of n, but instead of this, let's say if you have like this, order of n plus order of log n, what will be your answer? What would be your answer? Oh, n log n. Guys, what are you doing? Niranjan, n plus log n. I'm asking about the final answer. You cannot answer like this. See, for this, let me paste that particular picture also. Big O kill sheet. I think so. We have shared it in your class. So you have to go in this particular site. Let me copy that. You have to go in this particular site and you have to see the graph. Okay, you have to see the graph. Now, if I show you the graph here, then my graph would something look like this. Okay, so now see here that which is more in terms of order of n order of log n. Okay, this was my order of n, this was my order of log n. Now compared to both of them, where is my order of n lies in this particular graph? Okay, where is my order of n in this particular graph? To lie something here, right? What's wrong with pen? Will lie something here, right? And order of log n will lie something below that, like this. Okay, so obviously order of n is max, right? So whichever is max, you have to consider that only. Okay, right? Why? Because if I'll say that I have my n is equals to 1 million, okay, let's say I have big number like this. So compared to this, can't I ignore the lesser number from this, like 100? है ना? So it's like water in ocean, है ना? We can say, ठीक है? So in ocean, whatever water drops, water droplets you will take or you will add into it. It doesn't matter. Similar to that, it doesn't matter whatever you are adding into this ocean or not, है ना? You can also remove from that. You can also do something else. Correct? So we have to consider the higher order every time. Yes, Niranjan, we have to consider the higher order every time, right? ठीक है? Hariharan, you are also clear. I guess you also answered that. Okay. Now, okay. So see, there are, like, I'll say that there are three kind of complexities we can discuss about here. Okay, let me go one by one. Okay. So let's say if I talk about this order of one, then after I have order of n, then after I have order of n square, then after I have order of log n, then after I have let's say order of n factorial. So there are different kind of names of it. Okay, let's say this will be called my linear complexity, because every time, why it is called linear? Because its graph something look like linear graph. Okay, like linear graph it will have, right? Okay. Now if I have let's say my n, है ना? If I have my input as order of n, so its graph will also look like something this. Okay? because based on input also it will be growing, because it's something called as what? It's something called as what? Sorry, it's called as constant. Okay, sorry, it's called as constant. That is why its graph was look like constant. It's linear. That is why it's called as linear. Order of n. Order of n square will be called as quadratic graph. Okay, okay, quadratic graph, because its graph will look like something this, like this. Okay, it's quadratic graph. If you have learned in the basic 9 10th maths, it will you know this. Now, or log n will be known as logarithmic graph, and n factorial also we can say n raised to n. It is known as my factorial graph. Okay, factorial complexity, right? Okay. Now, now, since this is clear to you, can I say that uh, I have, let's say I have this particular complexities. I have for I equals to 0, I less than n, I plus plus, and here I have for j equals to 0. Nobody will answer on this. Okay? Nobody will post answer on this j plus plus, and I am saying that my n is equals to m. Okay, and this will be done like I'm printing I comma j. So what will be the time complexity of this? I will be asking this to Hariharan. Hariharan, you can post your answer. Hariharan, you are in trap. Okay, no worries. Suraj, you can also answer. Suraj, are you in the class? Okay, you can also answer this. Okay, okay. Nilanjan, you can also answer in this. Okay. Uh, mm, 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 mm. Parag, you there? You can also answer in this, please. Yes, Deepak, you can also answer in this. Okay, everyone can answer in this now. Okay, so initially, since it's nested loop, yes. So see, Hariharan, you know the answer, but you like rapidly you want to give answer. That's why you mistake, है ना? That's why you did a mistake. I posted this, है ना? In the yesterday's class or in the previous class, we did not have this condition, है ना? That is why it was in the previous class. It was n into m. For those who did not attend in the last class, please watch that. For this, if my n is equals to m, can I say it is nothing but my n only? So if you have this, what you will do? Since this is my nested complexity, this is inside, this for loop is inside this. So whenever you have nested complexities, you will multiply both of them. Okay. So this will be run for my n time. This will also run for my n time. So it will be n into n times. That will be my order of n square times. Yes or no? Right? अब गलती नहीं करोगे ना? Okay. Let me try to confuse you little bit. Now, let's say uh, 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 it can be order of m square. Yeah, anything like that. Okay. Can I, like Priyanshu, can I say that I can also put in this n, I can also put m here. So if I put m here, it will be order of m square, right? Okay. So Dipanshu is asking that, guys, please tell us, if you have a complexity like this, okay, if you have a condition like this, what will be your answer? This is my n, this is my m. What will be your answer? This is very good example, by the way. Dipanshu, very nice. You observe that. Nishant, I am asking that previously you had a condition like this, n is equals to m. Now I have a condition like this. If I have this condition, what will be my answer? What will be my answer, people? Everyone can answer on this. Okay? Everyone can answer on this. I am waiting. You have to tell me what could be the correct answer for this. See, my m is bigger here. Okay? Okay. Chalo. Let me tell you the answer. Okay. Let me see the other answers. Uh, 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 n into m, iterative n into m. Okay. ठीक है चलो. So Dipanshu, what do you think? What should be your answer here? Has anyone tried to attempted this on basis of on pen and paper, or else everyone is answering randomly? Have you tried it, people? ठीक है चलो. Okay, so can I say that if my n is less than m, then can I say my m is bigger here? And this is my nested complexity. This is my nested complexity. Okay, so suppose if I have x here, if I have y here, then my answer would be x into y, right? Okay, so here my m is bigger compared to n. So can I say it will be like a dominating term, right? Okay, so let's say if this is running for n times, this is running for m times. Since my like, so can I say if you do not have this condition, can I say this will be run for n into m times, right? You know? So just tell me now, tell me properly if you see what will be the changes here if you have this. Is there any change? If yes, then what? If no, then what? Yes. See, it's no change because it is multiplying, right? If it could have been like this n plus m, then I can ignore this n and I can just answer as m, right? Or else I can also answer it like order of m also here because n is negligible compared to m. No? Anything would be fine in this. Yes or no? Right, people? Okay? Got it? Now, suppose मान लो कि you have the same thing like this. Let's say you have order of n square complexity here in this term. Inside, like in this term, you have a complexity of n factorial. Now, what would be your answer of this? This both are sequential term. See, this is my sequential term, है ना? So can I add both of them like this? Order of n square plus order of n factorial. Now, which one is more here compared to this and this? Which is more? n factorial na, है ना? As per worst case n factorial takes more step. Yes. So can I answer this like this, n factorial? I can ignore this term, right? Right. Now, now, if you got this particular thing, if you got particular this thing, then can I say that okay. So you remember we did multiple examples of this. Let's say I have like this. Uh, okay, I have something like this. I have a for loop for equals to 0, I less than m, I plus plus. And here I have for j equals to 0, j, let me think. Hmm, I think we have covered this. Let me think about it. Do we have covered about the log example like this? Like if we have j equals 0, let us do na. How come, how it will differ? This is on anyway revision class. So suppose my j equals to 0 here, and I have my j is less than log I, or else, and yeah, j plus plus here. And here what I'm doing, I'm just doing print j like this. So what will be the complexity of this? Think about it, then answer. Anyone can answer. Think about it first, then answer. Let's say I can, no, not 0, it will be 1. Okay, now tell me. Okay, so can I say it will be the n log n only, because this will be anyway run for n times, and for this n time, for every term it will be run for n time. So this n and this, sorry, this will be run for log n time because my condition is for log n. So for every this I, it will be run for log n times. So can I say it will be log n time? है ना? Clear है? ठीक है? I think so. We discussed about this, and I remember this. We draw about this. I explained you how many computer steps would be for each computer steps, and for each iteration. Okay. So this is what we have covered in the basics. Okay, this is what we have covered in the basics. Now, let me go to the like advanced problem of this. Okay. Then after I'll start with the recurrence relation, because in that I need to discuss a lot of things. Okay. So let's say I have, why we can't neglect in nested loops as we do in addition. Okay, let's say if you have this n and log n, do you think we have ignored anything? Do you think we have ignored anything? Like log n is way lesser than n. Like they are both like almost comparable terms, right? So we haven't ignored this, right? But instead of that, in previous question, so in previous question where n is less than m, okay, so in previous question I assume that n is very less than m, you know. If you have a thing like n is very less than m, then can you ignore this n, because m is way higher than this? See, you cannot ignore the things. Like if you have this compared to this, if you have this, then you can ignore this term completely, right? You know, otherwise you cannot. Okay, but to be honest, you don't ignore this term also. If you have this like very less than also, you don't ignore that term also in multiplication. Okay, how to write worst case if will be an infinite loop or stack overflow? So it depends. In that case, can I consider that case as like wrong or falsy algorithm? है ना? Do you remember? I told that whenever you have to compare any two algorithms, the first thing should be that your solution should be proper. Your solution should be right. Apart from that, like whenever your output is proper, then after we can compare it, right? है ना? ठीक है? Nilanjan, am I clear with your doubt? Nilanjan, where n is less than m, है ना? ठीक है? Now, ठीक है. So on that particular thing, since we are clear with this, we also discussed something about the log thing. Okay. So and then after we started quickly about the what will be our recursion, like how to find the time complexity for recursion. Okay. Then we have discussed about the time complexities for recursion. Okay. So this is what is very, 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 very important thing. So for those who have come up from the computer background now, they know that pretty much clear that in your first or second sem itself, your topic would be on this. Like you learned about the subject called data structure, data algorithm, data structure and algorithm analysis, right? So in that, your first topic was this to find the complexities. But since it was very first topic, you found it very difficult to learn. है ना? So that is why we are emphasizing very much in detail. I don't know how many of you are from the tech or how many of you are from non-tech, but this is what it is taught in the initial days of your of your days when you do not have any hands-on on how to implement the solution or the approaches also. So that is why it is like very crucial topic. Students are very finding this like problem solving very hard, because they don't know the logic also. Okay, that is why we first learnt about how to find the solution for recursion, then after we are learning about the substitution method and all. Okay, so if I say about the methods of it, my first method will be the substitution method. And trust me guys, compared to other methods, it is way lengthier and way time consuming, but we have to learn it also. You can find many solutions from this particular method. This is very important and this is very useful also, right? Second win will be your master theorem. It is also most important thing. And third one is your recursion or recurrence relation. Okay, or else you can say recursion tree. Okay, recursion tree. Out of this thing we have seen this particular thing, that is our substitution method. Okay, and this second and third method will be learned in future classes when we'll be learning about the divide and conquer thing. Okay, so in the recursion, like in the substitution method, do you remember that do you remember that whenever we were solving any recursive solution, we were seeing and we were debugging the from the call stack. So every function call would be piled up in this. Okay, these are nothing but my function calls: function 1, function 2, function 3. Not function 1, function 2, it's function 1 only, but with different arguments. Yes or no? In case of recursion. But in case of normal function also, if you see na, it will work as same way. Let's say if you have your function 1, function 2, function 3, function 4, then your function 4 would be resolved first, then after function 3, function 2, function 1, and then after it will be empty. So in normal calls also it will be behave like same, and recursion also it will be behaving like same. This is just for your information. We have also seen this in detail, in very much in detail. है ना? Right? So it will be true for recursion and non-recursion solutions as well. Okay. On that note, see, whatever solution we have discussed so far, na, in that our space complexity will will be always order of one only, because we did not use any advanced data structure in that. Let's say we did not use arrays, we did not use objects, we did not use any other data type or stack or heap. We did not use anything like that. We just used a variable. In that also we just called our function for one time only. That is why our space complexity for them would be order of one. Okay, But in case of recursion thing, let's say for an example, uh, let's say for an example, if you want to some or else just simple thing na, like why we are complicating, we are not problem solving, we are just printing the print for 10 numbers. Okay, print 10 numbers, we are just doing this task. So what we will do, what we will do we just write the program or recursively which will be run for recursive. Okay, so we will be focused on what, the recursive call, then we'll do the self work, then we will do the hit the base case. This is what we will do, you know. Okay, so in the recursive call what we will do, we just take our function with us and the rest of the thing will pass to someone else, you know, right? So uh so for that, like for this particular thing, can I say for 10 numbers, for 10 numbers my function would be called for 10 times? I don't know how many of you are getting this, yes or no? These are 10 times my function calls, okay, in recursion. Can I say that? है ना? ठीक है? So it will be my order of 10 only. Okay, it will be my order of 10. So can I say it will be my order of n? Because if I pass like 1 million input, 1 million numbers I want to print. So can I say it will be my order of n only? You know, this is what is logic is. Okay, so how many times your function is executing, depending on that you will be doing the or calculating the things. Okay, now since we have learned this, I don't think so yet. You do you want me to revise the Fibonacci series explanation once again also? Yeah, no, na. So that we'll start with someone else, something some else problem also, right? Yeah, Nilanjan, we are just considering worst case also. We will not ask about the, you will be not asked about the best case and average case more often. We will be asked, but not very much often. Okay. So now, if I just want to tell you the problem, yes, Priyanshu, please ask. With Fibonacci part. Okay, okay. So can I explain? Like, do you want me to revise every like entire problem, or you just want me to do the thing? How many of you just want me to revise the Fibonacci problem? ठीक है, चलो. Since many guys are requesting, we'll solve that. Okay. So yeah, and we will also do the quick like kick start only. Okay. So no worries. Start. We'll solve this particular problem. Then after we'll solve some other problem based on this. ठीक है. ठीक है, सो एक बार देख लो ये प्रॉब्लम, बिकॉज इसके बाद आई विल गिव यू टास्क टू डू योर ओन, दैट यू नीड टू कंप्लीट फॉर मी इन दिस पर्टिकुलर टास्क ओनली. ठीक है, विल कंप्लीट दिस फिबोनाची टास्क, then after I'll give you a break, and then after we will start with other problems. Making sense, people? Right? ठीक है, चलो. So in the Fibonacci series, now from now I'll be not looking into the comment section for a while. Okay, so please bear with me because I will be explaining you something important concept. Okay, how you have to tackle it, this is very important. If you know the problem or if you don't know, that doesn't matter. How to tackle the question, it is more important. Now first of all, you need to be clear with the solution. Let's say if I write my function as fibo, that I am taking my n inputs, and first of all my base condition be what, whenever my n is equals to 0 or whenever my n is equals to 1, in that particular case I need to return n, right? And otherwise what I need to do, I just need to sum up, or I just need to call my particular function again with the n minus 1 and n minus 2 inputs. Yes or no? Okay, this is what my code would look like, right? Okay, so yeah, so after you are clear with the with the solution, you need the recurrence relation. If you are not clear with the solution also, like in many cases, you will be given this particular thing, the recurrence relation of a problem. It will be look like this, like t of n is equals to what? T of n minus 1 plus t of n minus 2. Okay, this is nothing but my recurrence relation. Okay, so suppose if you don't know this particular entire program for some task or for some problem, that's fine. If you are clear with the recurrence relation, or if you are given with recurrence relation, it will be more than more than enough. Okay, plus c also. Okay, now can I say that for input n, can I say that for input n it will be run for n minus time, n minus 1 times, first of all, है ना? Right? So in substitution method, what you need to do first, that you need to find the recurrence relation. Then after your original work would be starting, right? है ना? Because what if you see here also, what I did, I just found the recurrence relation first, and I'll initiate my task, right? So can I say that for input n, it is nothing but a recursive call for n minus 1, for n minus 2, and constant operation for adding, है ना? For every input n, it will be adding what? This n minus 1 call, n minus 2 call, and this constant operation. Can I say that c is a constant, Nishant? ठीक है, c is any constant. ठीक है, okay. So can I say that see, can I say that for a longer period of time, if I have 100, like 1,000 inputs, or 10,000 this input, right? So can I say for this input, like for my 1 equals to 2, I can say, है ना? Because these both are near term, right? Okay, so instead of that, if I consider this, it will be also same, right? It will be also same. Difference is just for 1, right? So can I say here, for longer period of time, since this both are equal for longer inputs, can I say this will be also equal, you know, right? Okay, okay. So because here the difference is just for 1 iteration, right? Since here and here difference is just for 1 iteration, I can say that this both are equal term. Okay, for this t of n, right? Not this t of n. Okay, now what I will do, I will put this n minus 1 or n minus 2 in my original equation. Let's say if I'll put this, let's say t of n minus 1 is equals to, I'll put this n minus 2 in place of n minus 1 plus c. Okay, so it will be nothing but what? 2 into t of n minus 1 plus c, right? है ना? Right? So after this, you see that in your question, in your equation, you have this t of n minus 1 here. Okay, you have your t of n minus 1 here. So you need to find about this n minus 1. Okay, so if I'll put n minus 1 in place of n here, what I'll get? T of n in place of n, I need to put what? N minus 1. So n minus 1 plus c. Can I say that, people? Right? So it will be nothing but 2t of n minus 2 plus c. This is what my equation would be for n minus 1. You know, right? Now what I'll do now, this will be for n minus 1. Now I see that now in my question demands of n minus 2. So let's find n minus 2 only. You know, or else if you don't want to do that, then what we will do? We will simply put this n minus 1 thing, or this n minus 1 whatever we have found out in this equation. Okay, if you don't want to do that, then it will be look like something this 2 into, instead of this n minus 1, we have to put this. This was 2 into 2 into t of n minus 2 plus c plus c. Can I say? है ना? So it will look like what? 4, है ना? It will be look like 4 into, what's wrong? Yeah, 4 4 into t of n minus 2 plus this will be 2c plus c. It will be 3c. Yes or no? right? है ना? Now, after this, can I say that this is true for my n minus, if this is true for my t of n equals to 4 into t of n minus 2 plus 3c, after this, can I say it will become into t minus 3. So if I put t n minus 2, then after I have come to t minus n minus 3, it will be 8 and it will be nothing but my 7c. If I take another example of it, one step more, can I say it will be my t in n minus 4, it will be my 16 plus it will be my 15c, right? So if you do this, you will observe that it is nothing but, this term is nothing but what, 2 raised to, here it was 2 raised to 2, 2 raised to 3, 2 raised to 4. So can I say that it is nothing but my 2 raised to 4 into t of n minus 4 plus 2 raised to 4 minus 1 c, right? है ना? Now if you get this particular solution na, now your task is what, you have to generalize it, your task is generalizing. Okay, many students will reach this particular point but they don't know how, what to do after this. So you need to generalize it. Let's say if I put 2 raised to k in place of this power, I'll put k, then can I say it will be n minus k plus 2 raised to k minus 1 into c. Now your task is what, to eliminate it. Okay, anyway you have to eliminate it and you are done. Okay, so there is always one way to eliminate it, you have to remember that, or you have to just come up with practice on this. Okay, so can I say that at one place it is n minus k, so it will be t of 1 by some point of time, you know, at that time my 2 raised to k, and it will be, let's say, can I say that if my n minus k is equals to 1, so why I'm putting 1, because your base case is what, 0 and 1, right? So on that particular thing, I'm assuming that I need to do this particular thing 1 only, right? So I'm assuming that n minus k equals to 1. So if I put that, then my k would be what, n minus 1, है ना? My k would be what, n minus 1 only, right people, है ना? So if my k is equals to n minus 1, then what I need to do here, see, I took n minus k equals to 1. So can I put here 2 raised to k into, first of all, can I put it like this, minus into c. Okay. So now if you want to get this particular value of t of 1, you have to again go to your base case. Now pass 1 here. What you will get? 1. Yes or no? But in this particular case, your t of 1, as I have already told you in my last class, that your t of 1 would be 0. Okay. Your t of 1 would be 0, right? So in this particular case, you need to put 0 here, minus 1 into c. This will be what, 0 plus 2 raised to k minus 1 into c, right? Okay. Yes or no? Since this two things are constant one, I can ignore that and my answer would be 2 raised to k. Perfect. Make sense? I will give thousands, like I will give like thousands of examples. In that, this will be, yeah, Priyanshu, you can raise your hand, please. Yes, Priyanshu?
Yeah, hello. Am I audible?
Yeah, you're audible.
Uh, can you just scroll up where you start writing from the blue pen?
Yeah.
Yeah. So what my doubt is here, that t n minus 1 is equal to, why it's 2 here? Like it's t and keep our n minus 2 plus t n minus 3. So we have what we have done. We have uh, put the similar things like we have done in the case of t bracket n, this n thing.
You are talking about this one?
No, no, no.
Here.
From where you started from blue pen.
Okay, so here it is what, like, how come it's Tn minus 2, right? You are asking about that?
White's 2 here.
Yeah, why is 2 here? Here? This 2?
No, no, no.
This 2?
In the starting, yeah.
This 2? Okay, see, what we did, our T of n was what? 2 into T of n minus 1 plus C here. Now my
Right.
task is to find what? T of n minus 1 here, right? So
Yes.
what I need to do, if you want to find T of n minus 1, instead of n, put n minus 1, right? So if you put n equals to n minus 1 here, what you will get? Array, see, if you have this n minus 1, if I put n equals to n minus 1 here, what you will get? Instead of this n, put this n minus 1. n minus 1, and ये तो था ही. Yes or no?
It is similar to like t n minus 2 plus t n minus 3. So n minus 2 will be similar to n minus 3. So what we done, we write n minus 2 two times.
No, 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 no. No, what we didn't do that. Let me explain you once again. I think I am not getting you. Let me explain you once again this. So, are you clear why this both are equal,
Yeah, both are similar.
similar, right?
Yeah.
So instead of this
So
thing,
yeah. So what I'm asking is like as t n minus 1 is similar to t n minus 2, t n minus 2 will be similar to t n minus 3 or not?
no, because it is not in my recurrence relation. No? This is my recurrence relation. This is not my no normal. We can say like continuity. Like this is not like this continuity. Over this, you will get T of n minus k. This is not like that. This is my recurrence
Okay.
relation. This is my recurrence relation for this. If you see here, I'm just doing what? N minus 1 plus n minus 2. That is why I have taken this here.
Okay.
Right?
Right.
Clear? ठीक है. So guys, एक बार देख लो. How 2 to power k becomes 0. Okay. So can I say that anything multiplied to 0 will be 0? Nilanjan? है ना? Yes, Joseph is right. You have to put k equals to n minus 1. If you do that, like if you don't want to put that also, you will get that answer, particular answer. And see, after getting this answer, you can put T of 2 to the power n minus 1 here. Okay, also you can do like that, and you can also continue this particular thing further. Okay, you can also continue this particular thing further, like for an example, if you have this particular thing as, like, first of all, you need to find this particular 2 raised to k, right? If you want to find 2 raised to k, then can I put this particular k equals to n minus 1 here, right? So k, 2 raised to n minus 1 is what? 2 raised to n into 2 raised to minus 1. Can I say that? Yes or no? Or else I can also say like this minus 1 is ignorable, and my answer would be anyway 2 raised to n. Now it's clear. है ना? This will be also like ignorable term. Could you explain the part since I lost my connection? Sharad, you can watch your recording, but see, this T of 1 would be 0. So anything multiplied 0 would be 0. Plus you had this 2 raised to k minus 1 into c. This c minus 1 would be in a constant term, so it will be ignored. You will get this 2 raised to k. In place of k, you can put this n minus 1. So I'll be get 2 raised to n minus 1. 2 raised to n minus 1 is nothing but 2 raised to n into 2 raised to minus 1, right? So in place of that, 2 raised to minus 1 would be ignorable. Cool? Okay? Now, I'll ask you the question, then after we'll quickly take break. After the break also, I'll give you some time to think. In break, you can also take your dinner. If you have some time, then you can think about it. Okay. But anyway, after break also, I'll give you some time to think about it. Now, this is very important question. This is very important question. Let's say, mm, what I can give you is, हाँ, चलो, if you have a suppose recurrence relation like this, let's say T of n is equals to, let's say if my n is equals to 1, then your answer would be 1. Okay? And if your n is greater than 1, then your answer would be n multiplied to t into n minus 1. Okay? This is what your question is. Now you need to tell me the time complexity of it by using the substitution method. So many of you guys already know got the gist of it, that this is what my base case, this is what my recursive call. Cool. Okay. In last question we have solved one more question. When the time complexity n plus c we found till n minus 3 till n t of 1. In last question we have solved in the previous session you are talking about, Priyanshu. Let me see. I think I will have that. Let me see that. Uh, just a second. Are you talking about the sum wala question? Okay, so let me explain you that also. Okay, just ignore this for a while. So guys, in that particular question, okay, in that particular question we had a thing like, as far as I remember, it will be like this, like function, then we had a sum, in that we have a particular array, in that I, and we have that base condition as whenever my I is equals to list dot length minus 1, then I need to return whatever my list of I variable is. Okay, otherwise what I need to do, otherwise I need to do like this, let's result is equals to sum list comma I plus 1, and I need to return my result plus list of I. This is what my question is. If I'm wrong, if I'm not wrong, Priyanshu, this is what the question is. ठीक है, चलो. So in this particular question, if you see, then if you want to find your recurrence relation in that, okay, if you want to find the recurrence relation in this, so what you will do? What you will do? Okay. So can I write something like this, that T of n is equals to T of n minus 1 plus C, because can I say that for finding the sum of n natural numbers, you are recursively making call to n minus 1 element every time, and you are doing it for constant operation of result plus list of I, right? So using this particular recurrence relation, you need to find your solution. Now the question is how. Okay. So if you see here, recurrence relation is clear for everyone. I think it should be. It should be. Okay. So now if you see here, you are asked about this T of n minus 1 thing. Okay. So what you need to solve first, T of n minus 1 only. So if you put in place of n, if you put n minus 1, in that you will get what? T of n minus 2 plus C. Yes or no, Aradhya? Right? This T of n minus 1, if you put again back to here, then what you will get? What you will get, people? T of n minus 2 plus C plus C, right? Hai, right? Now if you see here, that I have n minus 2 now, hai, so I need to find what? N minus 2. So again I need to put n equals to n minus 2 here, right? I'll get what? T of n minus 3 plus C plus C plus C. Yes or no? Right? If I put this, like, this is what my n minus 2, right? This is what my n minus 2, this is what my n was, hai na? Yes or no, people? ठीक है. Oh, sick. Sorry. If I put n equals to n minus 2 here, I'll get t of n minus 3 plus c only, not c plus c. Yes or no? है ना? Why we are doing that contiguous? Okay, Priyanshu is asking something. Why here we are doing that contiguous thing is my question. Okay, ठीक है. Priyanshu, see, here why we are doing continuity, and here also we were doing that only. If you observe, you know, we were finding what n minus 1 n minus, then after we require n minus 2, that is why we founded n minus 2, you know. If we have requirement of n minus 3, then we'll find that. If we have requirement in n minus 4, we'll find that. But after this n minus 1 n minus 2, I got a gist that it will follow the same pattern, yes or no. Okay, the same thing goes here. The same thing goes here, that in that particular thing, one t of n minus 1, I will not have a proper observation, or I'll not have a proper idea how it goes. Okay, there is not a particular rule that you need to just follow whatever it take place here only, you know. I understood from your question is that you are telling me that, sir, why we are not doing like this here, like t of n minus 1 plus n minus 2 plus n minus 3 up to 1. Okay, I assume that you are asking me to do like this, t of n minus 2 plus t of n minus 3 plus up to 1. Why we don't do this? Because here recurrence relation is not allowing to do that. Okay, right? Now here, if you see, t of n minus 2 equals to what? T of n minus 3 plus c was there, right? है ना? So if you have now what? T of n minus 3 here, है ना? You have t of n minus 3 here. So can't you put this n minus 2 value into this? If you put this value into this, what you will get? T of n equals to t of n minus 3 plus c plus c plus c. Yes or no? है ना? So now if you see, you got a proper thing, that in first of all, you got t of n is equals to t of n minus 1 plus c. In this, where is this thing? Yes, in the second thing, you got, no, I think we did something wrong. uh, I think one c is missing, है ना? Hmm, just a second. Where is that? If I put t of n minus 1 here, I'll get n minus 2 plus c plus c. Okay, yeah, fine, fine, fine. So in the first case, I got t of n minus 1 plus c. Is everything is correct, nothing wrong. In the second, this is my second scenario. In that, I'll get what? T of n minus 2 plus 2c. This is my third scenario. In that, I got t of n equals to t of n minus 3 plus 3c. So can I continue this? And I'll continue this till it will become t of n minus k plus kc, right? Everyone? Yes or no? है ना? Or else I can say, if I have t of n, then I can say t of, like it will be what? T of n minus I only. Yes or no? Right? Okay. So I can generalize it by following some pattern. है ना? That is why I did that. Okay. That is the only reason why I did that. There, apart from that, there is no reason to doing that. So okay. So can I say that if I write properly, if I write it properly, then it will be what? T of n equals to t of n minus 1 plus c. T of n minus 1 would be t of n minus 2 plus 2c. T of n minus 2 would be t of n minus 3 plus 3c, right? And it will continue, go on and on and on until it will become what? T of n is equals to t of n minus I plus ic, है ना? Right? Okay, we'll continue till that particular point. And can I say just beyond that, the previous case will be t of n would be t of 1 plus, like, nc, you know, after it become t of n minus I, it will become 1 only, you know. And as I said, that t of 1 would be what? 0. Yes or no? Right? Okay, so can I say that it's, since my t of 1 would be 0, can I say that it will be what? T of n equals to, from this particular equation, t of n equals to 0 plus nc, right? Okay, c is ignorable, so can I say it will be order of n only? It's pretty simple, Priyanshu. Got it? Okay. Nilanjan, I'll just give you a question. Then after you can take a break. Okay. I hope it will be okay to you. Now you have this question. Just a second. Yes, standardize the equation. Correct. Okay. Now you have this question and you have to think about it. Sir, how this method helps in writing the code or improving the code? Nishant, this is nothing related to the code. Okay, this is everything. This is what we are doing. It is after code process. This is not anyway helping us by no helping us to code. Can you repeat the question? Okay, fine. I'll tell you the question. See, whenever my this is my equation would be right. Whenever my n is equals to one, just a second. Whenever my n is equals to 1 here, my answer would be 1. And whenever my n is greater than 1, then my answer would be t of n equal to t of n minus 1. You need to find the recurrence relation for this first, and you need to put the substitution method and you need to find the complexity of that. Do we need to put the n minus 1 in place of n? You need to do anything that is required to solve this question. Now if I just want to give you a hint, since this is your no first question, then you just need to see what is demanded in the question. Okay, you need to see the pattern how we were solving the other questions. Okay, how we were solving the other questions related to this. If you see that, you will pretty much sure about it that you will able to solve it. Now since my n equals to 1 is my base condition, right? And otherwise it will be n into t of n minus 1 if my n is greater than 1. For every call my n is decreased by 1, yes or no? है ना? For every call my n is decreased by 1 by 1 only, right? ठीक है? So can't you put like can you find the t of n minus 1 first, then find n minus 2, then put this particular two equation in whatever we found in t of n, then you will have three equation, then you can generalize your formula and then find what is needed, like what is like what you can do on this. Okay, I can say this is simple question, not that simple, because this is what this is required, like this is the first question, that is why you will feel some issues in that, but no worries, we'll solve that. Okay, try to attempt it and let me know after the break. Cool. Okay, making sense everyone? Right? ठीक है चलो. So we'll take for break for 15 minutes. We'll be back at 9:55. Dipanshu, that's awesome. Anyone else have any answers or they are trying still? I'll give you some time, to try this as well because many of you were on the break, right? So you can try now. I'll give you some time to solve this. Guys, can you solve this? Or you are still trying? What is the status? How about everyone else? Only two guys are trying and two or three guys have done. ठीक है, चलो. You can try it. I'll wait. जिसने जिसने भी n फैक्टोरियल आंसर दिया है वो सही है. ठीक है. Everyone else please try. ठीक है, चलो. Anyone who is still trying? Many of you guys have already answered. Let me solve it for everyone else. ठीक है. Just a second. Let me see if this makes a problem to us or not. Just a second. Okay, so what we will do here? Not able to answer. ठीक है, no problem. चलो. What we will do here is See, this was a pretty simple question. Okay, so in here we have, whenever we have n equals to 1, it will be our base condition. Otherwise it will be n into t of n minus 1 for every n which is greater than 1. Okay, so for every call, my n, for every call my n is decreased by 1, you know, right? So what I'll do, I'll first of all put t of n minus 1. Okay, now take, okay, let me just write it one second. Okay, let me, I have t of n is equals to n into t of n minus 1. That will be my first equation. In my second equation, I'll put n is equals to n minus 1. So it will be what? N minus 1 into t of n minus 2. Okay, right? If I put now, I have n minus 2. If I put n minus 2 here, it will be what? It will be n minus 3, you know, right? Oh, okay, just a second. If I put here n minus 2, then can I say that it will be n minus 3 into t of n minus 4? Am I correct? Am I correct here, people? Am I correct here? Yes or no? No, right? See, because you don't have to put your n here. Okay, you have to always put your n here. I mistakenly, or I have put this like this because you will not do this in your real time. Okay, you have to always put your equation here. So whenever I'll find n minus 2, I have to put n minus 2 here, not here. Okay, so it will be what? N minus 2 into t of n minus 3. Perfect. Okay, so it will be what? My second equation, right? Or else I can say it will be my third, it will be my second equation. Correct. Now we need to use what? Substitution method here. Okay, so you need to what? You need to do what? You need to put 2 in 1. Okay, so let's just put this equation here in place of t of n minus 1. We'll substitute it. So it will be what? T of n is equals to n into n minus 1 into t of n minus 2, right? But we already have t of n minus 2. Yes or no? You know? So if I put 3, equation number 3 here, what I'll get? N into n minus 1, then what I'll get? Into n minus 2 into t of n minus 3. This is what I'll get. Correct. Now here my main aim to terminate this. Okay, this is always, this could be always your aim, otherwise you will not able to find your answer. Okay, so your main aim here to terminate this term. Okay, because what I'll do is I will just take one smart move here. Okay, so what I'll do, that can I say that since this is what my n equals to n into n minus 1 into n minus 2 into t of n minus, it will be, just a second, we put 3 in 1, so it will be 3, right? It will be 3 here, if I'm not wrong. Correct, guys? ठीक है, यहाँ तक perfect है everyone, है ना? ठीक है. Okay, so what I'll do now is I will just do n into n minus 1 into n minus 2 into n minus 3. Can I do that? Let's say if I'll do n into n minus 1 into n minus 2 into n minus 3 into n minus 4 up to, up to, I'll have what here? I'll what have n minus I. Okay. So what I'll put here, n minus n minus 1. Okay. Till that particular point I'll go. Yes or no? है ना? Right? Okay, so till that particular point I will go, and this n and n would get cut because it will be nothing but n minus n plus 1. It will get cut, it will be left with t of plus 1, right? Okay, so now if you see in the question, it is already been given that if your n is equals to 1, your answer would be 1. Yes or no? So can I say here my answer would be what? N into n minus 1 into n minus 2 into up to the t of 1, which is what, 1. Can I say that, है ना, right? Or else I can also say that before this one I will have what, 3 into 2 into 1. I can also say that, correct? Now you can clearly observe here that it is following what, n factorial, n into n minus 1 into n minus 2 up to 3 to 1, right? You know, Suraj, this is what given in the question. If you see here in the question, it is given na, that whenever n equals to 1, your answer would be what, 1, correct? Okay. So can I say that it is following n factorial? But but if possible, do not write this question, do not write this as your answer. Okay, I don't think so this will be anyway giving like given in your options. If this is given, then this will be your answer, but if this is not, then you have to do further steps from this. Let's say how. Let's say if this is not given in your question. Okay, so what we will do, you will take n common out of this everyone. Okay, so you need to take n as a common thing. So it will be what, n into, let's say I'll take a common n from here. So it will be what, 1 minus 1 minus n. If I'll take common n from here, so it will be what, 1 minus 2 by n. Okay, up to 3 to 1, है ना? Or else if I take n common from here also, it will be what, n into 3 by n. It will be n into 2 by n. It will be n into 1 by n. Yes or no? This will be my answer, right? So if you follow this, if you see here, it is what, n into n into n into n into n into n. Now this will be anyway neglectable term, because see, like your, can I say my denominator is always increasing here? My denominator is always increasing. So if you see here, like which is more, like if you take an example, 1 by 2, 1 by 3, 1 by 4, 1 by 5, which is more here, you will observe that when the time it is decreasing, your value is also decreasing, है ना? So it is what, it is your neglectable, like negligible terms, this all. So you will be left with what, n into n into n into n into n. It is nothing but n raised to n. This is what your answer could be. Okay, either you can also write it as n factorial. If this is not given in your answer and as your option, you can also write it as n factorial. Okay, either this could be your answer. I hope, am I correct? Okay, not understand. Okay, Nilanjan, can I get in which particular? Okay, n raised to n. So Priyanshu, what I did, and until this point everyone was clear. Now what I did, that suppose मान लो कि आपके ऑप्शन में ये दिया है कि ऑप्शन नंबर ए में ऑर्डर ऑफ एन, बी इज ऑर्डर ऑफ एन स्क्वायर, सी इज ऑर्डर ऑफ n to the, no, n log n, and in your d you are given as order of n raised to n. Now n factorial दिया ही नहीं है ना, so you will be confused what could be your answer. So that is why, if this is a case, then you need to follow this pattern. What, that n factorial will always be equals to n raised to n. Why? Because if you take n common from every term, है ना, if you take n common from each and every term here, it will be what, and if you can take n common from here, 1 minus 1 by n. If we take n common from here, it will be what, 1 minus 2 by n. Or else you can also consider na, that these are the constant terms. If you don't want to do that, don't do that. Okay, if you are not getting it, don't do that. Now come on, tell me this 1, 2, 3, 2, 1. These are what, constant terms? Can I say it will be nothing but n into n into n into n? है ना? So it will be what, n raised to n times. I can also write it by this. Yes or no? Right? ठीक है, good. चलो, okay, चलो, fine. So now remember, now you got the answer, right? So now you have to, whenever you will write n factorial, you can also write it as the same way as n raised to n. Okay, it is clear. Okay, it is a very important point. We will use this multiple times in the future. Okay, whenever it is n factorial, we will write it as n raised to n. Now suppose this question is clear for everyone. This question is clear to everyone. Okay, Nilanjan, please tell me first line of T of n. Uh, which one? This one? Okay. So in this one, what we did nothing. See, what we had, first of all, we had t of n. Then after we found t of n minus 1, then we found t of n minus 2. And that particular, these two things we put here. Okay, if you put t of n minus 1 here, you will get what? This. You will get what? If you put this equation to here, what you will get? N into, this is what your equation was. Instead of n, put n minus 1. What you will get? You will get this, right? You yes or no? Now instead of this t of n minus 1 entirely, put here. So you will get what? You will get n into n minus 1 into t of n minus 2, which is what I have written here. Now instead of this t of n minus 2, put this entire thing. You will get what? N minus 2 into t of n minus 3. Right? Now clear, Nilanjan? ठीक है? एवरी क्वेश्चन में आपको यही अप्रोच लगाना पड़ेगा. ठीक है? इन ईच एंड एवरी क्वेश्चन ऑफ सब्स्टिट्यूशन मेथड you will follow this approach. If you solve more question, you will realize that you will be taking the same approach over and over again. Okay, so can I go with another question? Can I give you another question, people? Everyone? Okay, chalo. So I'll give you this question. I will give you some handsome time to think about it. I want correct answer from everyone. And in the previous question, I was pretty happy because everyone was correct. है ना? Everyone was correct. Okay. So in this question also, I'll give you like this. Let's say if I have one, then if my n equals to one, then your answer is one. Otherwise, let me think. I what can I give to t n minus 1 9 by 2? Okay, yeah, fine. This will be a proper case like this n by 2 and plus n. Okay, just a minute. If your n equals to 1, then your answer will be 1. Otherwise, it will be 2 t n by 2 plus n. It will be otherwise. Okay, you need to find the, you need to take the same approach here also. You will be having plenty of time. Think about it, solve it on your paper and pen, then after give me answer. It should have some rationale behind it. Okay, I was pretty happy in the previous question. I am expecting the same from every one of you in this question also. Am I clear, everyone? Question is clear for everyone? Any doubt? Otherwise means like when n is not equals to 1. Okay, you can consider like n greater than 1, not less than 1. Okay, what I for now, just ignore that case. Vishal, please think about it. How come you got the answer very very quickly? We don't have to see and give us answer. Okay, anyway your answer is wrong. Okay, so please think about it and let me know again. Okay, you have plenty of time, do not rush. Think about it and let me know. We are not I don't want to have the quick answer, I want the correct answer. Dipanshu, it's wrong. Ankit, it's wrong. Guys, you are still trying. Okay. Deepak, it's wrong. Uh, if it's order of n, it's wrong. Vishnu, order of 1 is completely wrong. Aradhya, order of n square is also wrong. Anyway, I can understand. Like it's using uh logarithmic thing. So I think you guys would be confused in that, but let's see. No problem. No, it's pretty simple. Aradhya, if I no tell you the solution, na, you will you will trust me. You will say that it's pretty simple. Okay, it's just that we don't know. Like you guys don't know the logarithmic things. You know, I'll explain you. But I'm in like I'm assuming least that some of the steps of yours are matching with mine. You know, I'll just accept this in a least way. Okay, it's not hard, Nilanjan. ठीक है चलो. Let me explain you that how to solve this. Okay. So what we will do here. See, whenever your n is equals to 1, you are given that your answer would be 1. Otherwise, it's like 2t n by 2 plus n. Okay. So can you see here we are using t of n by 2 like okay. So let's find t of n by 2 here first. Okay. Right. So if I'll find t of n by 2 here, what I'll get? I will get as t 2t of n by 4 plus n by 2. Right. Okay. So this will be what my first equation. This will be my second equation. Now in this particular thing, you will observe that it's demanding t of n minus t of n by 4. So I'll find t of n by 4. It is nothing but what 2t of n by 8 plus n by uh, n by 4. Can I say that? Can I say that? Yes or no? Yes or no, people? है ना? ठीक है? This will be what my equation number 3, right? Okay. Now after this, what I need to do that I will just multiply this thing here. You know, I'll just multiply this thing here, or else what I can do, I will put this particular thing into our main equation. Okay. So what we will get. So if you observe in the main equation, we have 2t of n by 2. I'll put this particular thing here. So what we will get 2 into 2t of n by 2 plus n by 2 plus n. Am I correct? Am I correct? Vishal, why no? Do you want me to repeat? ठीक है. See what I did. I just put this t of n by 2 equation here. Okay. So instead of this t of n by 2, I put this entire equation. So 2 multiplied by this entire thing. So this is what 2t of yeah. So it's n by 4 plus n by 2 plus n. Yes or no? सही है. ठीक है. Okay. चलो. Huh. So we had this now. Can I put this particular t of n by 4? N by 4 is ready with me. So can I put this particular entire thing here? Right? Or else let me just no, let me just do something else here. Okay, so what I'll do here, I'll just multiply 2 into like in this. Okay, I'll just multiply 2 here. So can I say it will be my 2 square t n divided by 2 square plus this 2 and 2 will get cut. This will be n anyway. है ना? Plus n, it will be what? 2n. It will be nothing but 2 square t n divided by 2 square plus 2n. Yes or no? है ना? Now let me put this t of n by 4. Let me put this thing now here. Okay. So if I put thing, this thing here, what I'll get? I'll get at 2 square inside this. I'll put this particular thing 2t n divided by 8 plus n divided by 4 plus 2n. Yes or no? Sir, please explain slowly. I'm confusing plot. Okay. Nilanjan, in which particular part you are confused? Okay, let me do one thing. Let me do one thing. I'll just complete first and I'll explain 1 second. Okay. I'll explain 1 second. Don't worry. Now, since I did, I put this thing instead of this. Okay, try to understand Nilanjan. You will get to know. Otherwise, I'll explain 1 second. Okay, no worries. So this is what n by 4. This is what n by 4. I will put this thing here. Okay, so I'll get what 2 square inside that 2t n by 8 plus n by 4 plus 2n. है ना? Right? So it will be nothing but if I multiply 2 raised to 2 here inside, it will be what 2 raised to 3. Okay, this 2 raised to 2 will be multiplied inner side. It will be what 2 raised to 3 t n divided by 2 raised to 3 plus this 2 raised to 2. 2 raised to 2 will be get cut. It will be n plus 2n. Yes or no? है ना? So it is nothing but what 2 raised to 3 t n divided by 2 raised to 3 plus 3n, right? So similarly, I got a gist that whatever my n value would be, it will be following the same. So can I say that after some point of time, like let's say 2 raised to 4 t n divided by 2 raised to 4 plus 4n. Can I say that? Similarly, for 2 raised to 5, it will be 2 raised to 5 n divided by 2 raised to 5 plus 5n. It will be follow this syntax. You know? And if I have this k times, then can I say that it will be following like 2 raised to k t n divided by 2 raised to k plus kn. Okay, you know, and you know that in the question it is given that whenever it is 1, it is n equals to 1, your answer is 1. So can I simply not put t of 1 is equals to 1 here? So now your task is what? To eliminate this term. Now you remember whenever we are coming at a saturation point, our main goal is to omit this particular task, omit this particular term. So can I put like n divided by 2 raised to k equals to 1, because I know that this is my base condition. It will be only stop if it hits base condition, right? So n divided by 2 raised to k equals to 1. So can I say n equals to 2 raised to k? है ना? So if I say n equals to 2k, now apply log both sides. Okay, if you are following me in my previous solution also, you will be getting answer till this point. After this point, it will require some mathematical knowledge. Okay, so how? Because I'll apply logarithmic value in the both sides. So what I'll do, log n equals to log 2 raised to k. Okay, now whenever you are dealing with log, you know that this is a rule of log, that whenever you have this value na, log m raised to n, your answer would be n log m. If you have studied 9th 10th maths, you know this. Okay, similarly in this, it will be what k log 2, है ना? Log n will be k log 2. Now log 2 will be what? Constant, so I will ignore that. So can I say my k is what? Log n? Yes or no? है ना? Yes or no? Since my k is equals to log n, now put everything in this equation. Now since my n raised to 2 by n divided by 2 raised to k was what? 1. So what I will do, 2 raised to k into 1 plus kn. Can I say that? है ना? Yes or no? Right? Yes or no? ठीक है? Or else can I say that instead of this 2 raised to k, can I put n here? Instead of 2 raised to k, can I put this here? So it will be what? N, instead of this n divided by 2 raised to k, it's what? 1. So it will be t of 1 plus, can I say this k is nothing but, Can I say this k is nothing but my log n? So I'll put log n here multiplied by n. So it will be nothing but t raised to 1 is what? T of 1 is what? N plus n log n. I'll take n common here. So 1 plus log n, right? Or as like just do na, like whichever is more here, n log n, whichever is more, n log n na. So your complexity is what? N log n. This is what your answer is. How many of you are clear with this? Easy, है ना? Nilanjan, you got it? Not clear for me. Okay. From first term. Okay, ठीक है ठीक है ठीक है. Don't worry. I'll explain this. No worries. ठीक है. Okay. Now, Nilanjan, what we did here? Have you attempted the last lecture? Okay, fine. So which part is not clear to you? Everything, so that I'll explain everything. Joseph, t of 1 is equals to 1. How? See, you are given here na, that whenever your answer, like whenever n is equals to 1, your answer would be 1. It is your base case. So whenever you are given this kind of things, your t of 1 would be 1 in that case. Okay? Last substitution part, n by 2. How it is omitted, complete, implemented every time. Last substitution part of n by 2. Just a second. Which part? This time, this part you are talking about? Or else just raise your hand, Niranjan. I'll explain that. Just raise your hand. I'll explain that everything. No worries. Uh, uh, uh. Okay, you can unmute yourself.
Sir, please go up, sir. Here the first you wrote Tn by 2 equals to 2 Tn by 4 plus n by 2. The 2 number, the 2 second term you have.
Okay, this one.
Yeah, this one. Yes, yeah, this one.
Okay,
From here. Yeah.
from here. So basically, you are telling me to starting, na? So just tell me the starting. I'll explain it. No worries. Okay. See.
Yeah.
Okay. So see what we did. What we did here is, let me revoke that. Okay. So what we did here, you need to, like t of n by 2, right? You need to t of n by 2. So we found that t of n by 2 by putting n by 2 in our main equation. Okay. So this is what your equation is. You need to put n by 2 in place of n. So if you put n by 2 in place of n, it will be what? T of n by 4 plus this n will be n by 2. This is clear, Nilanjan?
Yes, sir. Yes, sir. Yes.
Okay. Now this is what requires for us to find n by 4. So we found that by putting n by 4 into this, the same thing. You got this? This one?
Mm,
No?
So
Okay,
we have
let me.
put the n by 2 in the first term.
Yes,
2t.
yes. You have to put every time here only, unless it is not a special requirement. Okay.
Okay.
So
Okay.
first of all, we put n equals to n by 2 in this term. Then after we put n equals to n by 4 again on this term, and we got this two equation.
Okay. Okay.
Right? Do I explain this term, or this is clear?
Uh, yeah, please express, sir.
Okay, yeah, sure,
Yeah.
sure. See, what we did here, that in this particular thing, what we did, we put this particular t of n by 4, sorry, this t of n by 2 again here. You know, we
Yes, sir.
found t of n by 2, right? So we put this particular thing here. So what we get, 2 was there, right? So instead of instead of this term only, we put this equation number 2. Okay. So if you see here, it will be what? 2 into, you have to put everything inside this plus n. Can I say that? Yes or no?
Yes, sir. Yes,
Right?
sir.
If I multiply this 2 inside, what it will be? 2 raised to 2 t, n divided by 2 raised to 2. 2 raised to 2 is what? 4.
Yes, sir.
Yes or no?
Yes,
This
sir.
2 will be multiplied here and cancelled from here only. Yes or no?
Sir, from where it is cancelled?
Let me explain. See, why? If you multiply 2 inside, it will be what? 4t n by 4 plus 2n by 2 plus n.
Yes.
Yes or no? This 2 and 2 would be cancelled, na?
Okay, okay, okay. Yes, sir.
Right?
Yes, sir. Yes, sir.
This
Yes, sir.
4 and 4 will be what? 2 raised to 2 square, right? It will be n plus n. This is what I have written,
Okay, sir. Okay, okay.
right?
Okay,
So it
okay,
will be
sir.
what? 2 square t n divided by 2 square plus 2n.
Okay. 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 Okay,
right?
sir.
Right.
Yes, sir.
Now
Yes,
instead
sir.
of this two, like this is what n by 4, right? So we
Yes, sir.
found that n by 4 earlier. So we put everything inside here. Yes or no?
Okay. Okay. Okay.
है ना? Right?
Okay, sir. Yes,
And
sir. Yes, sir.
and we multiply this 2 raised to 2 inside this. So what we will get 2 raised to 3 t n divided by 2 raised to 3 plus this 2 raised to 2, and this 4 will be cancelled out like this.
Okay. The each time it is forming the term, we are substituting that term into this
Yes.
into the next
So
term. Okay.
yes,
Okay.
yes. So this term would be substituted in this, like in this equation. है ना?
Okay.
Then you will get this. And if you multiply it like the same thing here, what you will get? 2 raised to 3, like 2 raised to 2 was there, and 2 raised to 1. So what it will get? 2 raised to 3 only. T n divided by 8 plus 2 raised to 2 is what? 4 n divided by 4 plus 2n. This 4 and 4 gets cut. Yes or no?
Yes, sir.
So
Yes,
this
sir.
is what forming 2 raised to 3 t n divided by 2 raised to 3 plus n plus 2n,
Yes, sir. Yes,
right?
sir.
So it will
Yes,
be
sir.
what? 2 raised to 3 t n divided by 2 raised to 3 plus 3 n. Now from this it's simple. 2 raised to 4, 2 raised to 5 until 2 raised to k,
Yes, sir.
right?
Yes, yes,
Now,
yes.
now one of the guys has also asked me recently, just now, that why we are putting this as 1, right? So if you see, we now our aim is to omit this, right? This
Yes, sir.
term. So
Eliminate the
how
term.
to, yeah,
Yes.
how to eliminate this term? Only it will be eliminated once it will hit the base case, है ना?
Yes.
So
Yes.
here you
Right.
are given the base case. So whenever your n equals to 1, your answer would be 1, right? So
Yes.
how to, like, you have to do something like this na, to become this one.
Yes, sir. Right, sir.
Can I do n divided by 2 raised to k equals to 1? So it basically my n equals to 2 raised to k,
Yes, sir. Yes, sir.
right? So it's nothing but what? If I put that the same thing here, or else if I put the same thing, like I just multiply log both side, okay, first of all. So it will be
Yeah.
what? Log n equals to log 2 raised to k. This
Yeah.
power would become come before. So it
Yes,
will
sir.
be
Yes,
nothing
sir.
but k log 2. Log 2 is
Yes.
my constant 0.3010, if you remember, in the 10
Yes, sir. Yes,
standard,
sir.
right?
Yes, yes.
So k will be what? Log k will be log n. Yes or no?
Yes, sir. Yes, sir. Yes.
है ना? ठीक है?
L-
So now
la- Last part I have understood that
got it,
how
na?
it comes the n log n.
हाँ.
I am confused in the first part the how the n by two is get implemented every
Okay.
time we if I search.
Okay. Got it now?
Yes.
Now?
Yes, sir. Yes, sir. Yes, sir. Got
Okay.
it, sir.
ठीक है.
Thank you, sir. Thank you,
Okay.
sir.
Yeah. Welcome. Uh, NK. Please also explain NK as well. Dipanshu, which term? NK. Where it is? NK. I did not write it anywhere. Dipanshu, which term? Am I audible, people? K and which term you are talking about? I'm not getting it actually. Like it will be like anywhere. I did not write K or like I write K equals to log n and n log n. K times n. Okay, like here. Here you are talking about. Okay, so what we will get, like every time whatever my n is, you will be get the same in the denominator also, in the plus addition term also, right? So 2 raised to 4 t, 2 raised to 4 plus 4n, 2 raised to 5 t, 2 raised to 5 plus 5n. Similarly, can I write 2 raised to k t n divided by 2 raised to k plus kn? Can I write that, Dipanshu? है ना? So after this, what I did this n divided by 2 raised to k equals to 1, n equals to 2 raised to k, and apply both side log. Let me remove the round if you are confused in that. Dipanshu, now which term? Now which term you are confused? Like you want to explain me this? K equals to log n. Yeah, k equals to log n. Then after what we did? Then after what we did? After we got t like k equals to log n. Then after what we did? We put this particular, like if you see here in this particular term, this 2 raised to k is what? N. Okay, so I put n. N divided by 2k, we assume that it is 1. है ना? Here. So it is what? 1. Plus k is what? Log n. है ना? So you put log n. right? And this is into, this is not plus, okay? So this is what into n. So can I write it n plus n log n? So n is negligible as compared to n log n, so my complexity is n log n. Did it come from log n equals to k log 2? Yes, yes, it has come from this now, because log 2 is my constant term, so I can ignore that. So my k equals to log n. Right? So if you guys are confused here, you can also write it like this, like log n equals to k. So can I write k equals to log n also? है ना, दीपांशु? ठीक है? Okay. Okay. So can I give you another question related to that? Or else just do one thing. Just do one thing. I'm giving you some time. Write it on your own, on your like a note and like pen and paper, and then after we will quickly start with another thing. Okay? Because once you if you not write it now, if you do not write it, you will not get to know about it. Okay? So I'll give you some time to write this. Okay, complete it within like 5 to 7 minutes. Then after we will solve one more problem with this. Otherwise, if it's not covered today, then I'll give you as a homework. But let me try that will complete today. After that, also I have to solve one more question. Okay, I need some more time. No worries, just try to complete this. Everyone, this is for everyone, people. This is for everyone. Please try to write it. I did not guess n equals to n by 2. I did not get it. Is given in the question. If you see, Deepak, it is given in the question. Recurrence relation. Okay, so Shubham, I did not know that n by 2, okay, this where this n divided by 2 raised to k equals to 1. I did not know this. Okay, I had reached a saturation point wherein there is nothing more possible thing will be happened, and I need to omit this t term. You know, so by there is just only one possibility by omitting this t term is to hit this base condition. Okay, so what is my base condition here? It's 1, right? Suppose मान लो कि here your base condition is 2, so you have to put here 2, n divided by 2 raised to k equals to 2. You have to think about it. Okay, then after your base case would be hit now. If your n divided by 2 raised to k equals to 1, at that particular time what your n would be? Your n would be always be 2 raised to k. I hope this is clear, Shubham. In the previous scenario also we did the same, if you see. Okay, that is why I'm giving you some time to think about it, or you to log this in your notebook, and try to do not try to write it on your own. Do not see this execution. Once you are stuck, then only see this execution. Okay. Nilanjan, I can just zoom it out like this. Otherwise, if I zoom out, you will. I'm not sure you can able to see that or not. Everyone can see this every lines. Okay, ठीक है चलो. Then people, how many if you are done? ठीक है, खुद से किया तो समझ में आया ना थोड़ा, राइट? uh yes, please Dipanshu, ask. Meanwhile, I'll write another question for you. ठीक है? Let me zoom it out. Okay. How n by 2 is getting eliminated to n? Let me see. Where is n by 2? N by 2 is eliminated with n. Which term? This term? Like this is n and how it become this n by 2? How n by 2 is getting eliminated to n? Which term, Dipanshu? Can you please be generic? Or else raise your hand. Okay. Yes, Dipanshu, please ask. Which term? Am I audible?
Yes, yes, you are. Am I audible, sir?
Yeah, you are. Please ask.
So, sir, like in this, like initial lines where you have written this case for t n by 2, like you have written this, uh,
Okay.
there the n will be n by 2, and when you try to like substitute this step into the initial scenario, like this n by 2 get converted into n, like I can't get this denominator term where like
Uh,
whole.
एक second. Like this, see, t of n by 2 is equal to this is clear.
Yes, yes, this is clear, sir.
N by 4 is clear.
Yes, n by 4 is also clear.
Okay. How we will, like how this n by 4 we have calculated is clear.
Yes, yes, agreed, sir.
So in
Agreed.
which term you are having problem?
Like substitution of these term into the initial scenario.
Like t of n by 4, like n by 2 we have put here in that term.
Yes, sir. Yes, sir. Agree. Yeah.
So if you see we have put this n equals to n by 2 here. Okay. So what we get, if you put n equals to n by 2 here, what you will get, 2t n by 2 by 2
Correct, sir.
plus n by 2.
Correct, sir.
Now denominator would be multiplied, na? So 2t of n by 4 plus n by 2. This is what we have written here. This is
Oh,
what your question, or I'm getting something wrong?
no, no, like this is the like question which I was asking, but like I'm getting little confused there. Like,
So denominator, like whenever you have this, na, like a divided by b divided by c. So it will be a
isn't
b c.
yeah, isn't there will be like n by 2 plus n and whole divided by 2
N by 2 plus n
plus,
whole divided by 2. No.
yeah.
How? I'll say how. I'll say the how. Why? Okay. Just a second. See, what our requirement here is, see, what you have is, like you have t of n is equals to 2t n by 2 plus n. This is what you originally having, right?
Yes, sir.
Now you just need to put, this is what my n by 2 is, right? You just need to put t in place of this t of n by 2. You need to put this. Okay. So am I correct now? You need to just put this t of n by 2. See, this is t of n by 2 equals to this. So instead of this term, you need to put this now. Yes or no?
Yes, sir.
Right? So if you put this, what you will get? Instead of this t of n by 2, entire term of this you need to put here. Like t 2t of n by 4 plus n by
N by 2.
plus n.
correct, sir.
correct है?
Correct.
ठीक है? Now, what after this we did? What after this we did? We just multiplied it here. Okay, so that is what 2 raised to 2 t. It will be multiplied to this term also, right?
Yes, sir.
Like this, right? So this first term is over. In the second term, can't it be like 2n by 2 plus n?
Yes, sir.
This 2 get cut,
Like
not getting. Just a sec.
it shouldn't be like 4 and 2n by 4, right?
Wait. Are you clear with this step?
Yeah, yes, sir. I'm
This
clear
is
with
clear,
this.
na? This is clear how it came.
Yes, sir. It's clear.
Now, if you multiply this 2 to here, then see, let's say I don't have much space. Let's say you if you have like this, like a multiplied by b plus c, right? So what the answer it could be ab plus ac, na,
Okay, okay. Yeah, yeah. Now
right?
I'm getting, sir. Yeah.
है ना? So this 2 will be multiplied here also. This 2 will be multiplied here also.
And n by 2 also.
No, here it's not. This n by 2 also and this term also. So it will
Correct.
basically multiply to this and this,
Okay, okay. Yeah,
right?
yeah. Yeah, now I'm getting, sir.
Okay, ठीक है? Because 2 is not this 2 is not multiplied to here. That is why we are not multiplied it here.
Okay, okay.
Correct है?
Correct, sir.
ठीक है? Okay. Any doubt apart from this?
No, sir. Like it's clear.
Okay, ठीक है. Great.
Thank you, sir.
Okay, welcome. Okay, can I give you another question, people? Okay, what I'll do, I have two questions to give. I'll give you one question as homework, and I'll solve one question here. Will it okay? I have two questions. I'll solve one question, and give you one question as a homework. Okay. Now, uh, first of all, I'll explain what like which question I need to explain you. Okay. Then after in the last, I'll show you which question you have to do in a homework. Okay. So that this question says that your f of n is equals to 2n square plus 5n plus 1. Okay. Your g of n, you need to find your g of n, c, and n naught. Okay. I hope everyone remembers that. Okay. So whenever you need to find this g of n, c, and n naught, what you need to do? Okay. If you remember clearly, we solved multiple questions related to that as well. है ना? We put the graph like this. Like suppose this is my f of n's graph. This is my g of n's graph. Okay. This is my f of n. This is my c into g of n. And this intersection point is called as n0. For every n greater than n0, your graph should be hold true, and your f of n would be less than or equals to c into g of n. This is what we see. Everyone remembers that, है ना? ठीक है, right? So you need to find this c, this g of n, and this n naught for which particular point of time your graph would be entirely true. Now you remember, you can also tell me that your graph will be like this. This is also a correct answer, because for every f of n, your g of n would be like any values after this would not possible, you know. You can also give me answer like this. After this also it's not possible, but after this also it's not possible, after this also it's not possible. You need to give me the tight upper bound of it. So you need to give me solution of this as close as f of n. There can be multiple solution of this. Either it can be, you know, either this can be a solution, this can be a solution, this can be a solution. This entire solution would be true, but you need to give me the closest one. Okay. Now, since this is following what, n square, like second degree, so I will put first of all g of n is equals to n square, and I will check whether it will work or not. And I'll put the c as, like, let's say sum of it. Let's say 5, 2, and 8. Okay, I'll put as 8, and I'll find this n naught. How, for which particular point of time my value will be hold true. Okay, so let's say if I'll put my f of n is less than equals to c into g of n, then can I put like 2n square plus 5n plus 1 is less than or equals to 8 into n square. Now for n equals to 1, if I put 2 plus 5 plus 1 is less than equals to 8, 5 plus 2, 7 plus 8, 8 less than 8, this is true. Okay, so can I say that my n naught will be 1 here? Correct? Yes or no? है ना? Right? So I can write it less, like I can write this particular thing as, for every f of n, like for f of n equals to order of g of n. Okay, this was my solution, है ना? This was my particular thing. My f of n equals to order of g of n. Now what is my g of n here? It is what? N square. So I'll write is my like this as, my f of n will follow my order of g of n, which is my n square. Okay, so it will follow my big O of n square, where where for all of n is equals to or greater than or equals to 1, my value would be true. है ना? Right? So it's also true now, because for n equals to 1 it's holding true. So for n equals to 2, 3, 4 also it will be hold true. So this will be my closest thing here. Or else also I can do something like this here. Let's say what I can do. Yeah, I can also do something like this here. Let's say my f of n was 2n square plus 5n plus 1, right? So I can also do something like this, that my g of n would be following the same degree as n square, and I'll, instead of 8, I'll just put 4 here. Okay, I'll put my c equals to 4 here, and I'll check f of n is less than equals to c of g of n. Now what would be my value of n naught and c, whether this is true or not? So my n square would be what? 2n square plus 5n plus 1 equal to my f of n less than equals to 4n square. Yes or no? C equals to 4, and this is my n square, right? Now if I'll check for n equals to 1, then it will be what? 2 plus 5 plus 1 less than equals to 4. So I plus 2, 7 plus 8, like 8 less than equals to 4. This is what? False. This is false. So I'll check for n equals to 2 now. For n is equals to 2, let's say if I'll put it here, 4 to the 8 plus 10 plus 1 less than equals to 4 into 4, 16. 18 plus 1, 19 less than equals to 16. Now if you see, your difference is decreasing. Okay, so you have to try for n equals to 3 also. For n equals to 3, for n equals to 3, what it could be for value of n equals to 3? 2 into 9 plus 5 3 are 15 plus 1 less than equals to 9 4 are 32. Okay, so it will be what? 18 plus 15, 33 plus 1, 34, 32. Okay, so 34 is less than equals to 34. Now see, my value is also decreasing. Okay, sorry, it will be 4 into 9, 36. Okay, so it will be what? My correct answer here. So can I say for my graph n not equals to 3, everything will be true for me? So can I say my f of n is equals to order of n square for all n greater than or equals to 3, it will be true? Can I say that? Everyone, can I say that? Okay, right? Now suppose मान लो a house equals to 4. We assume that, Joseph, in previous example also we assume that. Okay, there is no rational behind that. Okay, you just have to assume, you just have to find the closest one. Okay, now let's suppose if I have like f of n is equals to same 2n square plus 5n plus 1. Now let's suppose I'm assuming my g of n equals to n cube. Instead of n square, I'm assuming n cube. Okay, so n cube will be upper bound of it or not? N cube will be upper bound of it or not? है ना? See, this is my function, this is my n square, this is my n cube. So this n square is also your upper bound, this n cube is also upper bound, but n cube is way larger than your n square, so I should not no consider that. Yes or no? Yes or no? But see, if you consider this, like for example, if you consider this, na, then let's suppose you see c equals to 4 if you put, okay, so f of n is less than equals to c into g of n. So f of n equals to what? 2n square plus 5n plus 1 is less than equals to 4 into n cube. Now, if you see for let's say for n equals to 1, will be what? 2 plus 5 plus 1 less than equals to 4. 7 plus 8 less than 4 is false. For n equals to 2, it will be what? 4 plus 10 plus 1 less than equals to 4. 8 for the 32. Okay, 14 plus 8 15 less than equals to 32. It's true. It is true. है ना? For n equals to 2 is true. So can I say that my f of n will be equals to my order of n cube for all n greater than or equals to 2? Can I say that? Joseph, again, I have just put C randomly. है ना? There is no rationale behind this. If you see in the our previous examples also, if you just see our previous examples also from the previous classes, okay, if I say, then let me open the previous examples if I have in my deck. Just a second. Mm, mm, mm. Okay, so we consider the example of, let's say we consider this example, right? Let's say we had fn equals to 3n plus 8. We had this or not? Do we had that? You know, right? We had that 3n plus 8, right? So for this, what we assumed that for every n greater than n0, we have to find it something, you know, right? So what was our definition was saying that you will be having order of g of n, where, and for f of n you will be having order of g of n. For function of n, there exists a particular constant n0 and c such that you will be having your constant as like this: 0 less than equals to f of n less than equals to c into g of n. This we have taught, you know, this you have seen. This will be hold true for every n greater than or equals to n0. Now your task was to find c n0 and g of n, correct? Okay, so what we did, we assumed that our 3n plus 8 less than equals to this c into g of n will be 4 into this will be g of n will be like many times it will be of the same degree. We also seen here where it will be not in the same degree, but it will be not valid since it will be more upper bound, है ना? ठीक है? So in that example we consider this, we consider c equals to 4, g of n equals to n, and we found n0, है ना? We found n0 after which value it's true. Yes or no, Joseph? Right? So as I said that it will be always your hit and trial method. Okay, there can be multiple answers that can be true, but you need to find as close as possible. Cool. ठीक है, everyone? Can I go for homework of today? Can I go homework for today? Okay, ठीक है, चलो. So for homework for today is, and I will assume that many of you guys will do it for your own sake, not for me, not for anyone else, just for you. Okay, don't lie to yourself. If you lie to me, if you lie to your friends, everything will be fine. Don't lie to yourself. You have to try this. Okay, so let's say if I'll be having we did that n by 2 thing, right? So first of all, let's say if I having 1 for every n equals to 1, and if I'll be having t of n minus 1 plus log n for otherwise like n greater than 1. Okay, you need to find recurrence relation for this. And for this particular task, I'll just tell you as a hint that whenever you will be having your log m plus log n, it will be answered into log m into n. This will be, I think so, useful for this question. Okay, this is just for your information. This was taught in your 9th 12th standard. This is just for your information. N equals to n minus 1. You need to start with this, na Joseph, just correct, you need to start with this. First of all, you need to find t of n minus 1. Okay, just as the same scenario we did earlier. Okay, so if you find t of n minus 1, then it will be what? You need to find it, you know. Then after you need to find t of n minus 2. Let's say if we put 10 t of n minus 1, it will be what? T of n minus 2 plus log of n minus 1. Now it is asking to solve t of n minus 2. It will be what? Again, it will be what? T of n minus 3 plus log of n minus 2. Correct? Okay. Now you need to put this particular two, like you need to put this equation into this, and instead of this t of n minus 2, you need to put this. Okay, and then see how your equation will be forming, and you need to resolve that. If I'll be, no, I'll try to solve it, because if I try to give you a hint, na, I will eventually solve the entire question. That happens many times with me. Okay, so it is sufficient for a hint, or else I'll explain everything. I'll also explain entire question right now. No? Okay, chalo. So in the next session, first of all, I'll ask that whether you were able to solve this question or not. If not, I will try to explain that. Will it be fine? Okay. Okay. So on that particular note, we will stop our today's session. Any doubt for this today's session? Because from Friday, we will be starting with the introduction to sorting algorithms. Okay. There are many classes of sorting now. Friday would be your first class. Cool. Revise recursive problems too if possible. Okay. See, in the doubt session, I'll take your doubts for recursive questions, and I'll also no solve some of your problems which you want me to revise in recursion. Okay, making sense, Joseph? Okay, chalega. Okay, chalo. So on that note, we will stop today's session, and we will meet on Friday. And for the permutations questions also, I'll give you some other method to solve on Sunday. Okay, on the doubt session. We solved it on one method, but I'll also solve in the native method what we have discussed initially. Okay, so just remind me that also. After I asked today at start for big notation, will it be discussed in doubt session? Okay, Nilanjan, you want me to discuss about big notation? Okay, can I explain right now? In doubt session also it will be fine for me. If you want right now, I can explain that. Okay, fine. Okay, chalo. For this for everyone, this is for everyone. Okay. So for big O notation, I will explain in terms which I don't think so like I have explained till now. Okay. So what to mean by big O notation? Okay. If I say about, will not hurry. Okay. We'll explain step by step everything. Don't worry. It's okay. It's if time some like 10 to 15 minutes here and there, it's okay. Big O notation. Now, see. Uh, see, I'll write this. That's like this particular notation is used to. Can I say it will used to express upper bound? No, it is used to express upper bound of our algorithm. That it will guarantee that no, in worst to worst situation also, it will not go beyond this bound. You know, it is basically used to represent that. That is why we are telling this at telling it as big O notation. You know, it like it also represent, it also represent the worst case of an like worst case. Okay, it also represent the worst case time complexity. Okay, worst case of an algorithm. Okay, now for an example, the longest amount of time of an algorithm, you can also tell that. Okay, for an example, you can also tell that the longest time for the given algo. Okay, it is like what the meaning of this, the worst case also. Okay, now let's say there are some notations here also. Okay, there are some notation here also. We already seen that, but since we are starting it once again, I'll explain that. Whenever whenever your f of n is equals to g of n, okay, your f of n will be always of order of your g of n, where your g of n will be your upper bound. Okay, if this is exist, if this exist, uh, if this exists for a value of positive integer n, then can I say that for n and n naught, then can I say for every n greater than n0, my this value would be hold true, है ना? Yes or no? Right? ठीक है? Such that my f of n, such that my f of n would be always less than or equals to c into g of n, where c is my constant, g of n is again what, my upper bound, right? Now this is true for all n greater than or equals to n naught, right? Okay, so can I say therefore my function of g of n is an upper bound for function of f of n, है ना? As g of n will grow together, like as g of n will grow faster than f of n, yes or no? If this is my function, okay, if this is my g of n, then can I say at initially for initial part, this g of n, this g of n can be less than or equals to this f of n, or less than also, है ना? See here my f of n is bigger, g of n is lesser. So for initial values it can be true, but at some particular point of time, let's say for n naught, okay, after this n naught point of time, it will be always like greater than of my f of n, can I say? And this is what meaning of upper bound, that it cannot be go beyond of this, है ना? Right? Uh, Nilanjan, you got what is upper bound? I think so. It's previous comment, or you want me to explain in little bit more term? Okay. So, uh, see, what do you mean by upper bound? Okay. So, can I say that if, let's say, if my, mm, yeah, if this is my array, okay. If I say that in my Mac, this is taking 1 second, in my Pentium 4 or in my dual core Intel, that is like very old CPUs, you know, with 1 GB RAM, this kind of things. It is taking, let's say, 5 seconds to run this program. Okay, to sort this array or to print this array, anything of this program. Okay, so can I say that right now very hardly like 2 or 3% of people are using this particular kind of CPUs, right? Nobody will use XPs and this Vistas thing right now, है ना? Everyone will use some advanced processors there right now, है ना? In this class at least. Okay, so can I say that my algorithm will run no less than this 5 second? It will be hard to hard case, it will be equals to 5 second, but in any case it will not take 5.1 second also. Can I say that, Nilanjan? है ना? Right? So can I say that this is what my upper bound is, that after beyond that there is nothing is possible? Yes or no? Similarly, if you see here that beyond this point, like initially it will be true, like right now also Deepak is having like dual core in our class, right? But after this particular point of time, there will be no value which will be greater than from this. This is my maximum or like danger zone. Can I say that, Nilanjan? Right? Yeah, max possible values. You can also tell that. है ना? This is what I mean by upper bound. ठीक है? So here, this is what our equation is for upper bound. Na? F of n is less than equals to C is some my constant and G of n is my upper bound. है ना? G of n is what my upper bound. It is followed by some constant value which is C. And your task every time would be find C, G of n and n naught. Am I clear now, Nilanjan? ठीक है? This is what we mean by big O. है ना? And every time, as I already told in this session also, mm, 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 where it will be, I think that will be more difficult for me to export this as PDF today because we have zoom in, zoom out. Mm, there are three cases now: base case, worst case, and average case. If you remember, right? We discussed somewhere. Uh, okay. Yeah, this one. है ना? So out of this is what my big O notation. Okay, Nilanjan, ठीक है? So now just try to rewind the things and see what we have covered in the previous classes also, and try to solve the same question again and try to solve some extra questions again also. Okay. Now C into G of n is worst case. Yes, it is what? No, it's upper bound. It's not worst case. It's upper bound. है ना? Your worst case is what? Your worst case is order of G of n. Okay. This is what your worst case for any f of n. Clear? Right? So every time if I anytime if I write this O na, quickly this should be come up in your mind that this is nothing but my worst case. Clear? Cool. Okay. Chalo. Any other thing that anyone wants me to discuss? Anyone? Everyone is clear up to this point? Dipanshu, I think no. Log n factorial. Okay. Okay. See, Dipanshu, I don't want to tell you in this class, but see, Dipanshu, you cracked this 90%. Okay. Like you can also write this as an answer, but similarly, you remember? See, I'll tell you. Okay. I'll tell you this. Remember, I gave a hint to you. I gave a hint right now for everyone. What I hint I gave? Yeah. This I hint I gave na. The for log m plus n, it will be log mn. Right? So suppose मान लो कि if you have log of n factorial, then can you write log of n raised to n, Dipanshu? Right? So this n would be come up in the beginning. So n log n would be your answer. Okay? Awesome that you have solved. See, Dipanshu has already solved that. So I did not want to reveal the answer in this class, but since Dipanshu has asked me, I could not resist myself. So everyone, please try at your home and come up with the solution in the next class. If not, I'll solve that. Will it be fine? Making sense, people? Everyone? Chalega? ठीक है? Okay. So we will meet and on Friday. And till that time, good night and keep revising the things. We'll meet on Friday. ठीक है? Good night. Chalo. Thank you. Thanks for attending, everyone. Good night and keep revising the things. Tomorrow you'll be having like a black day. Like black day means like free day. So please try to practice on that class also. Okay? Okay. Chalo. Thank you. Chalo. Bye.